All right, starting recording. Thank you, Nick, for taking the time to speak to us, to the AI community. How not to do data science. Quite looking forward to see how we can avoid pitfalls in the future.
Yeah, we thought we, you've got organised plenty of talks throughout the year, and we've had loads of speakers talking to the community about the great things that we've done and some of the really interesting projects and developments that we've been working on. We thought we'd, because we're coming closer to Christmas, we'd keep it a bit more light-hearted and talk a little bit about what we've observed in something like 50 years between the four of us of data science practice, and some of the things that kind of made us giggle and chuckle a little bit, some of the crazy things that we've heard, it's not really about bashing the companies that we worked for before. It's more about a light-hearted kind of look at some of the things that we've heard, and then also explaining, in our view, what is the right way to kind of do data science, and how you can, take some of these statements that we've heard and turn them into something which is a bit more constructive. So there we go. I'm going to hand over to Ushashri now, who's going to be in the driving seat for us.
Before that, Nick, you want to introduce yourself a little bit, because
yeah, so we've got all of that under Ushashri's control. So she's going to tell you about the agenda, and then I think first item is introduction. So
okay, cool. Because not everybody is from EPAM in this meeting, right?
Right. Yeah, I can see there's some people from EPAM. Some people who've
but obviously
just joined EPAM as well. I'll notice some people have been with EPAM for a bit longer.
Yeah.
Some Manchester City supporters, which is a bit of a shame, but never mind.
I can't seem to be able to share. It's saying that I don't have access.
Okay. Okay, now it should be okay.
All right, amazing. Thank you.
Amazing. All right. I'm amazed myself, right? Cool.
Go ahead.
So I'll go. Nick, do you want to, should I start, or do you want?
Yeah, go ahead.
All right. So thank you very much for attending this talk. And as Nick already mentioned, that we are here to bust some of the myths on data science practices, and we'll try to show you how to do it. And we take you through the process for enabling data science in an organization. We talk about our journey, our experiences, a little bit about some of the case studies that we have worked on, or we've known our companies to do. And also this will kind of show you the true capabilities and strengths of data science in a business, and then how it relates back to you. So we are all part of the UK data science consulting practice. Do I introduce everyone, or do you want to go?
Maybe we can just go in turns.
We have Nick first.
So I'm Nick, and I worked in quite different range of industries. I started my career with a particular interest in marketing, but then I noticed that marketers were more interested in what we call fluffy bunnies rather than hard facts. And that was always kind of grinding at me. So I started to become interested in data like that. And so I did a lot of work in marketing analytics. I worked for an advertising company. I worked for a company that had like a big loyalty program in the UK in retail. And then I moved on to a price comparison website in the UK, which works a lot with insurance companies. So I started to move a bit more towards insurance risk. And then I completed my transition to what a lot of marketers call the dark side, which is credit risk. and I had a couple of roles in consumer credit risk, in lending, and I then did a stint in corporate risk as well. So used data science and analytics in all these kind of areas. Eric?
Yeah, I'm Eric McVitie. I'm a manager and data science consultant in Nick's team. I'm a recovering economist. So I started out as an economist doing economic forecasting primarily, and then moved to one of the, well, I think what is the world's largest credit bureau, but that might identify it, Consumer Credit Bureau, and working on the economic side there, but gradually made a transition into sort of the bridge between economics and marketing and analytics and credit risk analytics, and then sort of gradually drifted more hardcore onto the credit risk side. So that's how I've made my way into data science by the back door. So from doing sort of small data econometrics and forecasting to doing bigger data, at least credit risk analytics. Thank you.
Thanks. Hayley?
Hi.
Yeah.
Sorry,
Hi,
I forgot I was on mute. Yes, so I've been working for about 5 years in data science. I started off at Betfred in an online gambling division.
Gambling, you called it gaming last time we spoke.
No, I said gamble. I'm saying the gambling companies want to whitewash, sugarcoat it and call it gaming, but that's why I call it gambling, because that's what it is. I then moved to the financial services, which was good fun for a while, and now I'm with in Nick's team at EPAM doing consulting and working for a credit bureau.
Okay, and finally, Ushashri.
Hi there. So I was working as a software engineer before, and during that time, I kind of got interested in data science, and which is why I decided to change my domain and move to software data science. And it's quite interesting. It's more about looking inside data and trying to gain some new insights from that, and that's really interesting to me. And initially, I also worked in supply chain domain, and now I've also worked in finance domain and a lot of banking, insurance based industries.
Okay.
Cool that we are EPAM heavy feed in this case. Right? All right, no problem. That was a joke.
Good. Cool. Ushashri, if we move to the next slide. Okay. So we thought by summarizing a little bit what we think a data scientist is to start with, and data scientist is really at the intersection for us of computer science. It's not a computer science expert, but someone that can get a computer to do what it needs to do for the data analysis purposes. Also somebody who's generally quite fond of maths and stats, and something very often forgotten, which is business domain or domain expertise. So a data scientist is somebody that needs to be able to understand what the business problem is and be able to solve that. And then next slide, in terms of just a quick diversion, just because a lot of these examples that we're going to talk about later, they relate to a supply chain finance company, which is something that we have in common between Ushashri, Hayley, and Eric and myself, is that we all used to work for that company. So just a super quick explanation of what supply chain finance is, because it might help understand some of the examples later on. Essentially, if you think that you're a big construction company, you have loads of contractors that work for you, for example, some painters and decorators. It would work on the building sites where you're building a huge building, for example. Now, when you're a painter, you give your invoice to the construction company for the work that you've done, and the construction company will typically tell you, well, we're big, therefore we define the payment terms, and you're not going to see any money from us for 90 days because our payment terms are 90 days. So that's where you find some use for a supply chain finance company that can have a relationship with both the supplier and the buyer, and say to the supplier, in this case the painter and decorator, we'll pay you the invoice straight away, and then we'll get our money in 90 days from the buyer, in this case the construction company. Now, in order to do that, the finance company needs to have a lot of capital, and that capital typically tends to come from the investment market, from funds. So if you think about investment banks, they often have funds which are set aside specifically for the purpose of supply chain. So this is how it works. There's two main models to supply chain financing: SCF, which is buyer-centric, which is the example that I just described with the construction company and the contractors. And then you've got the reverse of that, which is AR financing, where the relationship is mainly with the suppliers rather than the buyer. But if you think about some suppliers, they can be huge companies. So if you think about Apple, for example, they are a supplier, and they could have that kind of financing arrangement because they supply many different buyers. Cool, next slide. So I suppose now we're going to get into some of the anecdotes that we gathered through our combined experience. And so this is some of the things that we've learned as data science practitioners whilst working for the respective companies that we were working for in the past. And so I suppose let's start with my all-time favorite one, which is I often get advice on who I should hire, even though I've led several teams over the years, and I've built teams from scratch, and you know, in the case of Shastri and Haley and Eric, these are teams that, you know, stick together and maybe even move to different places together. I still get a lot of people that give me advice. So one day I got told, Nick, you should really go out and hire a weather forecaster for your team. And I was thinking, that's okay, that's interesting. How you know, why is that? And it was still, well, you know, you're making predictions in your team, right? And you'd never find a person better at predicting than a weather forecaster, right? Like, yeah, I suppose you see where you're coming from, but I'm not sure that they'll be that happy to kind of sit down and start coding in Python. But so that was a good one. There's also Nick, you know, we want really high caliber people in our company, so only go out and hire PhDs or MBAs, people like that. And again, I think this in data science just is absolutely just doesn't work. I think that you have some PhDs who are excellent data scientists. I think we've got one actually on the panel this afternoon. But you also have PhDs who are just terrible data scientists. You have PhDs who, you know, who get so much into depth and the depth of the details that they completely forget about the bigger picture, and they're actually fairly poor at delivering anything. And then similarly, you have, in fact, the best data scientists that I've had the privilege of working with, they didn't have any particularly high qualifications as well. But this is a fairly common myth within the industry that nowadays, because the data science practice has become more established, that the only way that you can make your way into data science is by having a PhD in computer science, in mathematics, or something like that. I would definitely not go by that.
By the way, Nick, a couple of questions here, if you don't mind.
Yeah, sure. Let's keep into that interactive, like you said.
Okay. Do you still see this trend of hiring PhDs, or it's gone already? I mean, it's getting better, right? I think than a couple of years ago.
Yeah, I definitely think so. I mean, there are certain companies which think that they need to have a certain caliber of people, and that caliber of people can only be measured through the level of education that they have. And then there's some of the companies, admittedly sometimes smarter companies, which are happy to kind of hire a breadth of people and judge people more on what they can do or what they've done already, rather than just on academic qualifications that, you know, in instances could have been obtained many years ago.
Because right, I mean, I don't know, but in reality, right, only a very few people are doing, you know, new algorithms or trying to find new ways of having algorithms being much smarter, right? So, I mean, there's little research, right? That's what I wanted to say, right? It's more application or using of tools or than fundamental research, I guess, right?
I think you're absolutely right, and in fact, you're kind of helping the flow of the presentation, because you're kind of introducing some of the other points, which are, you know, the algorithm is the most important thing. So sometimes people think that, you know, the bulk of the work that is done by a data scientist is around the algorithm, the mathematics of it. And actually, the bulk of the work is around working with the business to understand and define what the business problem is, and also on the data side. And in fact, in my experience, most of the, if you just look at the how predictive a data science delivery is, I'd say that, you know, the most difference that you can make is typically through the data rather than the algorithm itself. And by now we also kind of know a little bit more which algorithm works well in which scenarios. So, for example, you know, we know that for computer vision, deep learning will work really well, and maybe if you use I don't know, support vector machine, it'll work a bit less well. But then similarly, you know, for other kind of use cases, we know a little bit more what works really quite well. So there's probably a bit less time which is being spent on trying loads of different types of algorithms, different families of algorithm. And I would say, you know, for me, in my experience, the biggest difference that you can make is by creating data items or bringing in new sources of data and combining it with the existing data sets that you have. That uses that generates a huge uplift normally. I suppose carrying on with the theme, one that I also really quite like is this kind of impression that you can just lock clever people in a room, and if you lock them in the room, they'll just come up with something you know, good at the end of it. And the reality is that, you know, if there's no data infrastructure to work with initially, it's very unlikely that no matter how many clever people you lock in a room, they'll be able to kind of magically come up with something. There's also the similar to that, just get some data and work on it. You know, that kind of principle of like you need to kind of just get working without actually planning what your delivery is and planning how it's going to be implemented. The biggest frustrations that I've seen with data scientists over the years is that they work really hard on a POC, they get to really good results, and then it never makes it into production, it never gets used because that aspect of things doesn't get looked at the beginning. And so for me, the whole planning is really, really important within that. What have we got? What else we got? Models are self-learning. Yeah, they are self-learning. You can make them self-learning, but I suppose there's two huge things about this. The first one is in a lot of industries, you probably don't want to make them self-learning. You know, for example, if you work for a lender, a mortgage lender, a bank, you know, would you be ready to kind of press that button that would refresh the model automatically without any input? Would you really be ready, knowing all the regulatory risk that is behind it, knowing the risk that you incur as a person if you're found to be giving loans to people who should never have been given loan in the first place? Are you really ready to press that button? The answer to that is that in most instances, you know, you can't have a fully automated self-learning mechanism. And then the other reason is because I think that, you know, as humanity as a whole, we're still a little bit at the beginning of our journey here. And as often when you're at the beginning of a journey, you get to kind of understand where things go wrong. And we constantly have examples of things going wrong. So you may remember, for example, this chatbot that was developed by Microsoft about 3 or 4 years ago. And this was kind of completely self-learning, and it was going to ingest the tweet, I think it was, and converse with and discuss topics with people and so on. But within, you know, completely removing the fact that human beings by nature are also sometimes got a little bit of an evil side to them, or a bit of a playful side, which might turn bad. And so within something like 48 hours, that chatbot, that self-learning chatbot, turned into a horrible chatbot that was kind of misogynist and praising Hitler and so on. And so it had to be taken offline by Microsoft to then put it back online, and still it didn't work, and then they took it offline for good. So there's loads and loads of examples like that, because we're still at the beginning of that journey, and therefore, you know, models being self-learning, I think we're still a while away from having that as a kind of a mainstream within the industry. I suppose just a bit aware of time, I'm going to just pick one more, which is maybe the one at the bottom there, which is around I don't need data, I just need a really good Rolodex. And this is kind of to illustrate that sometimes, you know, ML, AI, data science, you still need to do a lot of convincing to people within organizations. It's not a given that your solution is going to be accepted straight away. It's not given that people want to make the effort to understand that it could bring them something better or help them in what they do. So we used to have an example where, you know, I initially approached the head of sales, and I told him, you know, we could, using data, we could actually help you convert your sales a lot more efficiently, and also we could identify the prospects that you would be better for you to talk to. And the answer I got that day was, I don't need data, I just need people, expensive people with a good Rolodex. So, you know, we just dialed the number.
That's interesting, right? Because in fact, also I read somewhere, I don't know what's the percentage of models that really go into production, but that's not a very large number, right? It was like maybe 30% or whatever, right? Out of the models that were developed in test, in development, right, or prototype, right? Not many are really going into production, right? So maybe also due to the fact that it's difficult to maintain later on, right? But that's a different topic.
Yeah, this is also something that we're going to talk about later in terms of the emergence of the new kind of waves of trends that we see in data science, and the operationalization of machine learning products, which is becoming a lot easier over time. And this is also a big topic within data science. Absolutely.
There's a question here. I don't know if you see the question in the chat, but probably yes or no, I don't know. But
yeah, so from Tuana, we absolutely definitely see a lot of companies who don't even actually really know what data science is, or who have a lot of misconceptions as the ones that we've seen on the screen here. And Tuana, hopefully, you know, through the course of this presentation, we're going to show a little bit how company by company you can close the gap internally. But doing that at a wider scale, I think this will probably happen naturally, because more and more companies will understand the benefits and the pitfalls of data science, and understand exactly where it brings them benefit, and that will encourage adoption over the years. Cool. Let's move on maybe to the next slide, Ushashri. just to make sure that we can keep on track with time. So we have here what we think is our journey to become data-driven, or ML-led, we call it. And so you can see that, there's different areas where you can start from a fairly early maturity stage, and how you can kind of move across the different stages in these areas until you get to a much more mature kind of state. And I think the important piece here is that, it's more than one element. It's more than just data or people. It's a combination of all of these elements which will really allow you to become truly ML-led. Thanks, Shashri. Next one. So what we've done a few times in the past is we design data strategies to help people and companies on that journey towards becoming ML-led. And very often you have data which sits at the core of everything that we do. And again, this is something that, people sometimes tend to forget, but without data, data science doesn't exist. And then on top of that, you have the culture of the company, which is often the most difficult thing to change, the people and the skills that you want to recruit, and then the technology aspect and the platform. So we designed that strategy along 4 main points: build the data assets up, hire a multi-skilled team, deploy analytics environment, and then create a data-driven culture. And then here at the bottom here, I've got an example of a typical machine learning pipeline and the type of blueprints that you can develop when you do that several times. And as you know, at EPAM, we have quite a lot of these because we've done that kind of work with a lot of different companies. Next.
There's a question for you.
Oh, yeah. What is your experience with machine learning pipelines provided by hyperscalers like Azure and so on? How confident are you regarding the different statistical models that these pipelines offer out of the box? So we all tend to work with the 3 main clouds and on-prem, and so we've worked with kind of traditional pipelines, some of them that you can't even call pipeline, and done some work with the hyperscalers as well. In terms of what they offer out of the box, I don't know whether I already have a strong view as to whether this is the next big trend or not. I think that at the moment, there's already so much that you can do with bringing the data into an analytical environment or a machine learning environment, and all the work that you can do around the cultural aspect and the implementation aspect of what you can do, that this is probably at the moment the area that we would tend to advise companies on the most. But it'll be interesting to kind of see how we use these a bit more. And then in terms of so this is, I suppose, naturally kind of links to some of the things that you can do to enable that, to build these building blocks, these foundation layer, to actually enable successful machine learning within the organization. And so this is, again, a collection of things that we've done in different organizations. But one thing that we found very often is the data team, the analytics team doesn't even have necessarily access to data which is pre-formatted for them to work with. So sometimes they have to use raw data and data which is completely unsuitable for doing machine learning at scale. So now we don't mean to say that there isn't a place for that in terms of research activities that data science teams would do or an incubation team would do. What we mean by this is that in terms of doing data science at scale, you need to have a strong data foundation, which includes the availability of data in a nicely pre-prepared format for the data scientists to use. it also often, one thing that we see is that data comes from different systems, and it doesn't link up very well together. In fact, we've worked with companies in the past where there was no ID as such. Everything was joined on a company name, and you'll find that very often, with companies, particularly in B2B, where they kind of set up like a Rolodex on steroid, something maybe on Excel that they did. But the person that set that up initially never kind of thought about creating an ID. They just enter names. And then also when you work with organizational data, company data, there's often so many subtleties within the hierarchy of these companies that you really want to spend the time to make sure that you've got the right ID to the right company. Enabling tech, this is also not only enabling the data environment, but also the tech environment that a data science team needs. And then the way we would recommend very often to work is to do that 3-stage of first starting with POC, almost like a fail fast kind of way of working as well, where you try something, and if it looks good, if it smells good, then you carry on. But if it doesn't, then you can kind of cut your losses straight away and move on to something else. Then move into an MVP, and then into a fully productionized solution where you may want to bring other people around the table, like an MLOps engineer or a DevOps engineer or someone like that. We found as well that by changing the processes that are being used, it can also help enormously the team itself. So for example, we used to get a lot of requests directly sent to us, so people pinging Haley direct and saying, Haley, can you do this? And this is really not conducive to, again, being able to scale up. And it's not conducive to the wellness of your own team as well, because you don't have any clear data on your own activities when you allow that to happen. You don't really understand the number of requests that you fulfilled, and you don't really understand how they've been prioritized and so on. So we changed that. We created a single point of entry for all the requests coming into the team, and we also changed a lot the ways of working within the team, and made the team engage a lot more with the business, but once the initial prioritization piece had been done, rather than engaging with the business early on and then not engaging with the business anymore. And we like to create these hybrid teams where we have a data science person who works directly with a risk person. So even within organizations, we always recommend that you have members of the business team that are nominated to work on a specific data product delivery. And then spreading the word in data governance, I'm going to skip on these because of time, but spreading the word is a really important part of having this data science adoption within the organization. And if you don't take the time to do that, then it just doesn't happen. And sometimes it's a bit difficult to justify taking the time to do that, because you could just be more productive by just doing some more work. But actually, if you don't spend the time to tell people what you could do for them, what you've done successfully, but what you want to take to the next level, then it just doesn't happen. Mm. So now we're going to talk into practical examples of some deliveries that have been done once.
Just one more question before that.
Yep.
So you would say the data scientist, and maybe that's such an obvious statement, but the data scientist focuses on data, right? And not so much on algorithm and ML pipeline, right? So there are different skill sets required, right? In the depending on which stage you are, right? So and I think we tend to mix up everything, right? Because the data scientist is not a machine learning engineer, it's not a DevOps, and so on and so forth, right? So maybe that's also something we could I mean, not now, but clarify at some point.
Yeah. I think there's of course, we're in an industry which is quite prone to buzzwords anyway. Everybody wanted to talk about big data until a few years ago. Now, if you talk about big data, you're almost seen as like a dinosaur. And so, there's a lot of kind of new buzzwords around roles that have appeared recently. And I think that, a data scientist, I think the message that we really want to give here is that a data scientist needs to understand algorithms, and it will do work with algorithms. So he will create a neural network and spend time, creating hidden layers and adding different nodes to the network architecture and so on. But where you can really make a difference is by spending some time on the data aspect as well, and spending some time with the business. And I'd say that, the algorithmic side of things over time has become a little bit more commoditized as well. So, before, if you wanted to automate the process of reading information from documents in your organization, you might spend time to, develop your algorithm from scratch to do that. Nowadays, all main cloud providers make available the tools to do that really easily. So don't reinvent the wheel, use these tools and use your machine learning knowledge for where it actually matters and makes a difference.
Yeah, I think this is what also Thomas was referring to earlier, right? Using some commodity tools from the various cloud providers, right, to help finally to speed up development of a business solution, right? You don't need to focus so much time now on maybe feature engineering, on text cleaning and stuff like that, right? You have the tools, right? And nowadays you can focus much more on understanding the data, and second, discussing with the business about the business problem, right? So which is a big advantage compared to a few years back, I guess, right?
Yeah, or you use a combination of them, which is you use the tools which are available to do a certain part of the job, which is, I don't know, extracting the information and maybe grouping it in the right way. And then you apply your own bespoke knowledge of algorithms on top of that to actually do a second round of extraction of information or something like, but the hard grunt has already been done by the tool which is available within the cloud.
And Nick, can I get you make a follow-up question here on this topic, this relationship between data science and business knowledge? I am a business analyst. I am a business consultant, actually, from the financial services. And for me, what I am very much interested is to figure out and understand what is going to be the role of a data scientist person in the next financial service project, as you said. So is this person who is going to be working very close with us, or we need to look for a data scientist person who has already a banking background experience? Or what is your take here? Or do we need to be both of us on the project? Or can I learn something on the go to work together? What is your take on the time of articulation and combination of these both roles?
Well, I think this is a really, really interesting question. And Jorge, if you don't mind me asking, are you from EPAM or are you not from EPAM?
I am from EPAM.
You are from EPAM. Okay, cool. Because this is really interesting as well, because this is something that we're going to progressively change at EPAM, which is that we want data people to become embedded within teams at EPAM a lot earlier on when we talk to clients. Now, if you have a person that is an expert in insurance, for example, he'll always have more knowledge than me. I'll never compete with an insurance specialist, with an insurance consultant, but I have knowledge of insurance as well, and therefore I have already some knowledge of the type of data products that an insurance company may want to be looking at, and also have knowledge of data products that insurance companies are not looking at currently because they're too early in their maturity journey, but that they may become really interested very soon. And so, this is typically the case within insurance or within banking, where typically because of regulation constraint, data science team have been a little bit shackled and restricted in the type of algorithms that they want to do, because everybody's scared that they're not interpretable and so on. But now we have techniques to redecompose these complex algorithms and make them interpretable and fit for a regulatory environment. So to answer your question, I think that it's always best to go as a combined team, where and where it works best is where you have that combination of huge domain expertise with huge data expertise, but business focus. We have developed at EPAM in the last few months some really interesting solutions within insurance. But this was very much because we had data people or data science people working effectively with a consulting team. And I think the consulting team was kind of surprised that we could, hold a non-technical conversation, and we could think in a business way. We could think about data as a value proposition rather than just talking in sigma signs and in plus and minuses that come out of our mouths, really. So we found that we managed to have a really, really productive, collaborative environment by having data science people who are business focused, and within the data science type of skills, you will have people that are not very business focused, and they need to be business focused enough to be successful within their role, but they don't actually necessarily enjoy spending time talking to clients and so on, and that's fine. But they also have people within the data science industry that are very happy to try and solve a business problem and talk to a marketeer, talk to an actuarial person, talk to specialists within industries, and come up with a really collaborative solution.
Okay, thank you very much.
Thank you, Jorge. So we're gonna walk you through a few examples of what you can then do once you've built that initial foundation layer of data. And so the first example is going to be talked about by Eric, who created a risk assessment metric that we could not have done without having reached that initial base layer that you need.
Thank you. Sorry, Shashing, move on one. I don't know if this is going to be a walk or a very rapid run, because I'm aware of the time, so quite quickly, but if there's any questions, I'll just throw them out. I was coming from a background in consumer credit scoring, where evidence-based, data-based decision metrics are absolutely the core of everything you do, and across retail financial services, that's fairly typical. In the B2B domain and the business lending domain in financial services, even at scale, it's much more normal for risk decisions to be made on a sort of ratings basis, with quite a heavy level of judgment involved, and where there's kind of a deep dive process into investigating particular companies as possible lending prospects. That's all very well and good if you're lending at fairly small scale, but it's clearly not scalable. And if your ambitions are to lend to very large groups of companies, then that approach is not typically going to work very well. So one of the use cases we wanted to work on quite early on was to develop some database scoring systems for credit as a primary sort of value add for the business, so that they could improve the credit decision process, they could make it more evidential, they could have a more accurate view of the credit exposures they were taking on. And in this business, those credit exposures could be really quite eye-wateringly large. and they could do that without imposing additional costs in a way that was scalable as the volume of lending increased. And the process for doing that was really quite straightforward in the technical data science sense. As Nick had said earlier, a lot of the effort is really about convincing people that this is what they want, understanding exactly what they want it for, and understanding where the data are and where the gaps in the data are that need to be filled before you can build a viable solution. Once you have those data in place and you're clear understanding what the business use cases are, the modeling aspect is relatively trivial. You can build a machine learning model fairly quickly, and it will be, in general, fairly predictive. You can build an explanatory layer around it that gives you good insight into why it's scoring a particular way, and you can deploy it in a nice tidy pipeline for regular updates, because the tools to do that are available off the shelf effectively. So just to re-emphasize this point, that a lot of the data science is around that engagement with the business, understanding what is going to add value to the business, persuading the business that this is going to add value, getting their permission to access the data and to work through those options. So, and to work through that process, and then making sure that the thing can actually be deployed at scale in a production environment, and it will generate the value that you've promised. So in this case, we built a scoring system that was largely based on third-party data. It was running at quite a large scale in terms of the number of companies that were being scored, and we expanded the scoreable population in terms of companies that the company we're working for was interested in lending to, from about 30% to about 95% of the population, and generated just a much more user-friendly and insightful credit decisioning system around that.
One question here, Eric, regarding explainability, right? This is quite critical, right? In
yes.
I'm having a side conversation with one of the attendees on that aspect of black box models that nobody can explain, right? So how did you deal with that?
I think you just got to keep a rein on the algorithm. So, I mean, typically you would not present data items to the algorithm that you weren't happy that would land in the final model. And just do a lot of investigation about how individual data items are influencing the model outputs to make sure that you're comfortable with the business logic. So it's not a simple case of throwing data on an ML, letting it build a model, and then throwing an explainer at it and looking up on a bunch of graphs to say, yeah, that'll do. There's more work required than that. You need to be thoughtful about whether a data item belongs in the model, whether a feature is a plausible causal factor in what you're trying to model here, in this case, credit risk. Because ultimately, the business adoption, there's various reasons why ML models don't make it into production, but one of them is certainly that people don't trust them.
Yes.
So you have to build that trust internally and among stakeholders who think they understand the business that they're in, and they do understand the business they're in. So if you present them a model which makes glaringly odd predictions, or where the explanations that are being generated through Sharp or whatever algorithm are not ones which they would believe, then you've got a hard job to persuade them to adopt that model. Now, the model might be right, but if you believe the model is right, then you need to do the work to persuade them that the model is right and that their preconceptions are actually, in this case, incorrect. But it is a job of work. It's not, and I think that's the thing about these automated pipelines. I think these tools are tools. They're fantastic tools. It's great to have them available and not have to go code everything from scratch, but they are tools. And you need to use them as tools rather than let them run the process entirely. Okay. I think I might have had one more, but I'll happy to skip on to the next one. All right, sorry, yeah, this was just about scoring, but essentially yeah, if you don't know what credit scoring is, then essentially it's just a process of generating numeric metrics that will give you a sort of one-point view on the risk around some prospects. And in this case, yeah, it's merging, it's building a view or a metric from a bunch of data inputs, in this case through a machine learning system.
That could bring us to a few hours discussion, right? But
yeah, we don't have them.
Unfortunately, because we could speak about bias, and we could speak about explainability, we can speak about and so on, right? But we don't have time, unfortunately.
Okay, I'll pass on if you want to move on, Shasha.
So another thing that we can do with data is basically demand forecasting. So this is like a process of trying to look into the future to predict demand for assets or products or service by using historical information and to make an informed business decision. So if we look at an example of a demand forecasting model that we had developed, so you can imagine this to be like a logistic problem. So let's say we have a lot of boxes coming into the warehouse and we need to know beforehand so that we can manage inventory. And similarly here, sorry.
No, sorry, that was me. There was some background noise. Sorry.
So all right. So here, if we have prior understanding of the demand, it will allow the supply chain to stay on top of the game. So let's look at this Tetris board, and in the short version, we can, when we see the asset flowing in or a product coming in, we have very little time to make a decision. But if we can use something to extend this board, and we will basically have a prior knowledge and insight, a better understanding. So forecasting basically allows us to do this. So because we have access, if we have access more like to data, we can use it to forecast the asset flow. And in the second half of supply chain finance that Nick had mentioned, we have to distribute this asset to investors, and they have a capacity. So if we had this understanding beforehand, we can distribute this asset properly and create a better distribution plan. I think I'm not have too much time, so I'll just go very quickly. So if we look at, this is the technical aspect of it. Initially, we have to get this data. We need to put quality checks on that. We need to analyze it. We need to clean it. And that's a huge task that we have to do. This data needs to be sufficiently representative of what we are going to predict. Otherwise, it's garbage. And if you put in garbage, you won't get a useful information out from there. So we selected Facebook Profit Library for this. There were newer, like other libraries, and we could also do it on our own. But as we'd seen already, the discussion is already going on. If we have something already ready to use, we can do that. And we decided after comparing and evaluating that this was a good idea. After creating this model, it needs to be plugged back into the business and put into the business flow. So once we have this model created, we need to fit in with the existing business infrastructure and the processes, and that also requires some task, which and also this needs to be monitored, which is the next part, which is due to data drift and model drift. We need to keep this monitored as well. Yeah, I think I'll let Nick. I'll let Haley go on next.
So I'll very briefly be talking about conversion and cohorts in a non-data centric company. So just quickly, there just wasn't any data in the company, but it was more that there wasn't any interest from non-data stakeholders. They were a it was like a deal that had to be done, and they would just input the deal into their CRM tool with the most basic thing, only things that they needed. So the company name and the deal stage. The geographical region was actually auto-populated. So just moving on to the next slide. So what we did was we got the really limited data, and the only field we could really use was the geographical region, and we created a simple conversion metric. We just showed a simple conversion metric to kind of show, tell them about, you know, what the possibilities and potential that the data could be. And then with this understanding, they got really excited, kind of with what the data could do, and therefore they threw more resources at this project, and also more resources in terms of getting external data. So with the DMB data, we could get company size, industry, etc., etc. So finally, so once we had this, we had some really interesting conversion metrics, and much more detailed and better defined as well, because they were also putting their team's time into making the data better. And this finally allowed us as like a case study that we could show other teams in the company and get them to listen to us and get excited and just make their data better. Thanks.
Thanks. Maybe we can pause here and just see whether anyone's got a question for Hayley, or otherwise we can just.
Yeah, I have questions. In fact, right. I mean, from your practical experience, right? We hear a lot of times that the biggest challenge is data, right? Can you confirm that, or is it just? I mean, is it equally important than finding the right algorithm, or is it equally? I don't know. Right? What is the biggest challenge?
What would you say, Hayley?
I'm sorry, I didn't hear that. Was copy.
The biggest challenge is getting data, or the biggest challenge is the algorithm?
Data, definitely. Well, I mean, I'm quite biased after having worked on that project, but definitely, definitely, I'd say data. There's so many different kind of algorithms that you can try, and that you can. Are never structured. You can always tune them better. So I would always say data. Like they say, 85% of a machine learning project is spent on data preparation. You know, you don't spend a lot of time on model building. So.
And another question, I'm conscious of the time, but Andrew Ng is saying that before collecting too much data, you should test your algorithm first on small data, right? So what do you think about it?
I think it's Hayley, if you don't mind, I'll take this one. But
yeah, you can.
I think that I think this is maybe going back to, you know, this approach that we were describing before around doing a POC and maybe the fail fast idea. So there is, even though storing data has become really cheap over time, there is a cost to capturing data. And therefore, before embarking on the engineering work that needs to be done to capture a new data source, then you would ideally want to know that with a certain degree of confidence that the data product that you can create on the back of it will generate value. And so I think this probably is probably a good way of working. I think, you know, because we're kind of getting to 5 p.m. and you know, it's been really good, but I suppose that, you know, people will start to drop off. We might bypass the couple of slides that we've got now, and maybe just jump onto a couple of other points of conversation that we were going to mention in the last slide.
Anyway, I'm going to record, so you just go through, and you know, people can drop, but can still go back to the recording later.
Sure. And I think that, you know, we kind of put that slide as well to highlight a little bit the trends that we see, and again, I think that you know, in terms of the middle one, we see that barriers to adoption within organizations still remains significant, and we think that, you know, MLOps, which is the bottom point, has got a huge part to play. And for those of you who are not familiar with MLOps on the call, this is the role of a person that can take a statistical model that has been built by a data scientist and put it in a production environment, make it work in a production environment. Now, it sounds very simple, but it comes with a lot more difficulties than appears at first sight. One of them is about the different ways that you have to run an algorithm in a cloud environment, for example, and the difference in costs that can generate. So there's a whole piece to kind of really understand the best way to make an algorithm run, which Patrick, since he's decided to leave us to join one of the main cloud providers, is probably very, very familiar with. And so there's a whole role which sits a little bit between a DevOps and a data scientist, which is called MLOps, which can really help with that. And so we're growing a lot the MLOps capabilities within EPAM and also within EPAM in the UK, where we started to hire a team of MLOps people now. The other interesting aspect, I think, which is worth discussing before we open the floor to further questions, if there are any, is around ethical AI. And you can see that, generally within the way the world is evolving and rotating at the moment, there is much more of a consciousness about the environment, about the impact that data may have, either in a positive way or negative way, and also how it's being used. And similarly to the example of the Microsoft chatbot that I gave before, we also had another couple of examples with Cambridge Analytica of how data can be used in a potentially malicious way or in a manipulative way. And so there has been, a certain movement towards making sure that we can carry on using the possibilities that data offer us, but at the same time, also using it in a much safer way. And so at EPAM, we have started to look really a lot into ethical AI, and part of a panel actually to make that progress internally. But part of it is around interpretability and how you make a complex algorithm interpretable and understandable by a wider panel of non-data scientists, and ensuring that you don't discriminate consciously or unconsciously against certain minorities, for example, through the algorithm that you have deployed. There's also something really interesting that's going to happen next year in the European Union. There's a piece of legislation which is going to be coming into force in May 2022. And this has got a very similar ring to GDPR, for those of you who are familiar with the types of fines that GDPR can leverage against companies. If you are found to have a high-risk AI system, you can be fined as a company up to 30 million euros or 6% of your annual turnover. So huge fines as well. And so a lot more companies will now want to start looking into ethical AI, into interpretability, into discrimination, and whether unconscious bias is taking place. And I think, it's also interesting if we enlarge that conversation around, crypto, for example, and blockchain, and the fact that this form of money might not be as environmentally friendly as it first appeared, for example. So there's a whole movement, people thinking very differently about data, and I think this is what really is very interesting for our industry in the next few years as well. So maybe I'll stop here, and we just kind of open the floor, or kind of scoop at the questions, or see whether people want to drop further questions in the chat, or maybe even ask the questions directly.
There was one question from okay that we skipped from Nikita. I said, what do you think about different project management methodologies for data science teams? I think the most common methodology that work fine for classic software engineering cannot be applied to data science. How do you? That's a very good question. In fact,
It is, yeah.
How do you implement a life cycle in your data science projects? Which life cycle you use?
I think this is a really good question for Mikita here as well, because it could have been one of the points on the how not to do data science. I think the data science has kind of started to migrate over the years. It's often data science doesn't have its own home in an organization. It's often part of a marketing department, a risk department, and then more recently there's been more of migration into an IT department. And because of that, IT people being IT people, they just think that they can impose the same type of methodology onto the new addition to the team, which is data science. And we used a bit of that to our advantage by changing the process, as I said, and making sure that tickets are actually raised and that queries are raised via a single channel and so on. But at the same time, applying an agile methodology straight out of the box to a data science team, it just doesn't work. Often IT people don't really understand that within a typical standard data science project, there always is a little bit of a research element, a little bit of trial and error. Mm-hmm. There is a bit of data exploration that needs to be done, right? And so having, the typical agile methodology in the way it's organized and structured, and having this kind of quick succession of small tasks, this doesn't necessarily work well with a data science project, where sometimes you just know that you need to spend some time on stuff to either discover the next big thing or to discover that you're going in the wrong way. And sometimes you don't actually know in advance how much time you're going to need to spend on that. So I think Nikita's a really good point here.
I think, unfortunately, we are well over time, right? Anyway, most people can contact you, I guess, also through either internally, at EPAM, or through LinkedIn. What I'll do anyway, I'll upload the recording on the YouTube channel, and then it will be automatically posted on the Community Z page. And Nick can be reached at nickcarl@epam.com, obviously. We can be reached as a community on LinkedIn or on Community Z, by the way, together with my colleague Jorge and Miguel. Don't forget, next time in 2 or 3 weeks we have Max Alford as a guest, and Max was a guy who developed a Python library called Creme. Now it's been absorbed by a library called River, which allows to do incremental learning, right? Basically, you don't need to retrain the full model, but you can continuously train the model with additional observations. And it's quite interesting if you want to learn more about what people call online or incremental learning, right? So it's on December 17 in 2 or 3 weeks from now. All right. Thanks so much,
Patrick, for organizing and for inviting us. Like you said, if anybody wants to send us any questions after the event, then please do so. We're all very passionate about what we do, and all very happy to talk data science until the third round of drinks in the pub, by which time we stop talking about data science.
Spread the word. Spread the word so that we get more community members, and we can share with more people, and we can attract also more speakers. Thanks so much.
All right. Thank you all.
Bye.
Thank you.
Bye.
Bye bye, Nick. Thank you very much.
Thank you.
Bye bye, guys.